Well, good morning, everyone. This is John Benner. I'm here to present my literature review topic of growth promoting implants and their potential effects on carcass quality. So, to briefly talk about the topics that we will cover in this presentation, we will review what exogenous hormones are and why they are used in the beef industry, some of the basic mechanistic causes of action, and look at some commercial examples, of which there are many, of exogenous hormones, and look at the reported effects on cattle performance, as well as yield grade and carcass quality factors. And finally, we'll conclude with a review of scientific basis for concerns with exogenous hormones being added to beef products and any long-term effects that there may be in consumption of such beef. So what are implants? They are most commonly manufactured as a series of discs of compressed powder that contain an active estrogen or androgen, or in many cases both of those anabolic agents. So here's an example of one particular implant known as Ralgro, which is a synthetic estrogen known as Zeranol, and is being applied there in the middle, in between the middle rib area of the back of the ear. And again, the ear is the only approved application site for subcutaneous implants. So look at the active growth promoting agents. Again, we have androgenic and estrogenic components. The androgenic components are typically testosterone type of compounds. The synthetic and cost-effective method of an androgenic implant typically involves trenbolone acetate, and testosterone propionate has been used in different research trials as well. For estrogenic compounds, we think of estradiol E2, estradiol benzenate, and Zeranol. So the way these hormones work is they're once they're implanted within or under that dermal layer of the ear, they work to release or increase the concentration of growth hormone receptors, and really those are produced by the anterior pituitary, and the production and concentration of those are increased. They also increase serum insulin-like growth factor, which promotes hypertrophy and hyperplasia in some cases, and is attributed to overall cell growth. It also slows protein degradation while increasing protein accretion, and part of this is due to increased satellite cell response and activation, which has been observed in trials using exogenous hormones. So, beef cattle implants, we have a chart here of various implants that are used, made by various drug companies, and they have various levels of active ingredients. You do see progesterone here in some of these formulations, although progesterone we don't think of as an active ingredient in terms of growth promotion factors. Here you can see that the various implants, dependent on their dosage and relative potency, are approved for various classes of cattle. This particular chart is modified from Selk and others in a review of implants for stocker cattle. And this particular listing is 4 implants that are generally thought of being improved for stocker cattle. Additionally, you can see by this slide there are a number of implants that are also used for feedlot purposes, and we'll talk about a little bit later. A lot of these implants can be used in treatment protocols of once or twice implanting during the feedlot phase. Various implants have various half-lives of effective use, and there are protocols established for reimplantation of using various implants, as well as different products that substitute for a reimplant by having a longer acting implant as well. There are about 30 or so implants, and here we'll see a couple different commercial types. Here, Cinebex is obviously one. We looked at it the previous slide. Here's a Revelar application gun, Encore and Compudose, Component, and Ralgro. And different dosages are again approved for different classes of cattle. So Revelar XS is a longer acting implant and can be used as the manufacturer recommend, and in their research trials, is perhaps in substitution of a double Revelar S implant, or implanting Revelar S twice during a feedlot phase. So, what are the effects of implants on cattle performance? Well, real briefly, they're going to improve average daily gain and feed efficiency. And even though in most cases they're going to increase dry matter intake and hot carcass weight, they still improve feed efficiency through improved feed to gain ratios. So even though they're eating more, they're keeping more of that weight and still remaining efficient. These improvements can be seen probably in the range of 5 to 15%. It's pretty, we'll catch a lot of the improvements. However, you can see improvements in excess of that as well, with some implants and in some trials. So again, how this relates to carcass data, we're going to see improved muscle hypertrophy and protein accretion within the carcass, as well as the live animal, which will transfer to the carcass. And part of that will increase the loini area, or the longissimus muscle area. And the longissimus being a measure of carcass muscularity, we can see an improvement in the loini size, especially at the 12th to 13th rib. The increased skeletal maturity we can see as a kind of a modification of the growth curve of implanted cattle, and this is more pronounced in heifers, where you're going to see a little bit more advanced maturity score with skeletal features. However, overall maturity in terms of muscle is not really evident, as you would expect to see a little bit more collagen type of muscle development, which we don't see using implants. So with this improved muscularity, we're going to see improved yield grades. The data is not all in agreement with this concept of decreased kidney, pelvic, and heart fat. However, it has been reported as a decrease or no change in kidney, pelvic, and heart fat with implants. Lower marbling scores is one thing we do typically expect, and there's some different reasonings and theories behind these lower marbling scores. And perhaps in evidence of a lack of lipolytic effects of implants, we do not see a negative effect on 12th rib back fat. We don't see an increase either, but we don't really see a lipolytic effect by a decrease in 12th rib back fat for implanted cattle versus non-implanted cattle. So again, increased muscularity and yield grades in loini areas, and then decreased marbling scores. Effects on fat deposition. Reduced marbling scores, especially with reimplant programs, high-dose implants. We can see reduced quality grades. And typically we'll see a little bit of a correlation there with additional implants during an animal's life tends to lead to a little bit more of a reduced quality grade, although that data is pretty wide in range. Fatty acid deposition and composition within the loin eye, we do see a trend of a little bit more polyunsaturated fatty acids versus saturated fats. However, there is some limited data on that, and most of the fatty acid profile does remain unaffected statistically by implanted cattle versus non-implanted cattle. Adipocytes, actually we do see an increase with implants in terms of the number of cells per gram of fat cells or adipocytes. However, we do not see an increase in the size or the diameter of those implants, which may explain the lack of increase of overall fat characteristics. Now, the natural relationship between ribeye area and intramuscular fat, one of the prevailing explanations of increased ribeye area is in its connection to decreased marbling scores is the increase in ribeye area is not accompanied by an increase in intramuscular fat, and so therefore you have a dilution effect of the intramuscular fat, where you have more muscle tissue and more muscle area, but not a corresponding increase in marbling and intramuscular fat, leading to lower marbling scores and potentially lower quality grades. So here's kind of that recap where you're seeing maybe a dilution of the marbling. These stakes at the bottom aren't perhaps the best indication of that because they look to be the same size ribeye area. However, with an increased loin eye area, you may expect a lower intramuscular fat, as it does not keep up with the added muscle as a result of the implant. Now, the Warner-Bressler shear force is kind of an objective way to look at tenderness. There's been some reports of decreased tenderness with implants and the use of implants, and we do see that with implanted cattle. In terms of a consumer basis, tenderness of this steak is defined as being between 3.9 to 4.54 kilograms of force, or a Bradstreet shear force required to shear through a steak or to core the steak. Anything above 4.54 is considered tough. Anything below 3.9 is considered very tender. And with a few different studies, this one's from Rober and colleagues, we do see an increase in the toughness of the steak as defined by the WB shear force, but overall with most implant strategies, including double implants, we do see that the shear force still remains below that tough number of 4.54. Now, the timing of implants, you may wonder, well, how serious can the implant schedules be? How many implants could cattle potentially receive? And overall, you could look at a data, could tell you maybe 4 to 5 implants during a calf's life. Now, if a calf is a steer, it could receive an implant, probably branding, re-implant at weaning. Maybe later, prior to feedlot entry, they could receive one during the backgrounding phase, if it's an extended backgrounding phase. And then it could receive potentially 2 implants during the feedlot phase. And so we can see that these implants can build up, and we want to know what extent we might see a compounding of their effect. And the data kind of shows us that overall, we can see an increase with more aggressive, what we call aggressive or additional reimplant strategies and higher dose implants versus those that will have maybe 1 or 2 implants and then being a more moderate or lower dose and lower potency implant. However, there is some discrepancy in the data, and you can still find that that is not a straight line correlation if you get to study some of these implant strategies. But overall, you do see an increase in the shear force needed to core a steak with additional and more aggressive implant strategies. For sensory panel, this is the consumer sensory panel, is another method of measuring beef tenderness, and so trained sensory panels can rate on a scale of 1 being extremely tender and 9 being extremely tough. That overall, with different implant strategies, you do see an increase from the control with implants being a little bit more tough. However, there's not maybe as a expected difference within the implant strategies, just that they are above what the control is. And again, it is important to note that these are just sensory panel responses, and these are not shear force numbers indicating that these steaks are very tough. They're just a sensory panel of 1 to 9, with the implanted steaks being around 4 on that scale. Now, quick comments on implants' effects on hormone levels in beef. In terms of overall diet, implanted beef is not going to have a significant increase in terms of estrogenic activity, regardless of different implants, and certainly there'll be some differences, but overall you will not see a significant change or an increase in hormone levels if you're consuming steak from implanted cattle versus non-implanted cattle. So in summary, implant regimens are effective in increasing beef production efficiency. More aggressive implant schemes and reimplantations tend to increase consumer perceptions of toughness and do certainly decrease marbling score overall and tend to decrease quality grade and could potentially increase skeletal maturity. Can decrease skeletal maturity score, and there's very little effect in total hormone content in finished beef when compared to other foods in human diets. So please contact me with any questions. Thank you very much. It was a pleasure putting this together.